section 3.2. What are quadratic functions? Well, quadratic functions are functions that can be written in this form: f of x equal ax squared plus bx plus c, where a, b, and c are real numbers. A is a real number, but it cannot be zero. The reason for that is this: if a is zero, this quadratic term is going to disappear, and we will end up with a linear function, right? But we have already studied linear function in the first part of this course, right? So a never zero, so we get a quadratic function. Very good. Now, these quadratic functions, they come in different forms. The first form is this. It resembles the ax squared plus bx plus c, right? For example, f of x equal 3x squared plus 4x minus 7. This is called general form. General form. Now, but it's not the only one. The other form is this: g of x 5 times x minus 7 is squared plus 4. Plus 4. This is called a standard form. Okay. And it's a very important form because it contains a lot of information about the quadratic function. I will explain to you that. All right, so now the last form is this: x minus 3 times x plus 8, for example, right? This is what mathematicians call x-intercept form, sort of informally, x-intercept form, because it shows where the x-intercepts are, right? I will explain that. All right, so now, fact about these quadratic functions. The graph of a quadratic function is a U-shaped curve called a parabola, okay? So it turns out these quadratic functions, when graphed, they show a U-shape, a parabola, right? It could look like this sometimes, or maybe like this shape, right? Always exhibiting this vertical symmetry, right? Which is important. So why vertical symmetry is important? Well, it's a symmetry that appears a lot in nature. For example, think of a human body, right? Vertical symmetry, right? Yeah, due to gravity, perhaps, right? Yeah, very good. Now, all parabolas are symmetric with respect to a vertical line called the line, right? The kind of sets the vertical symmetry. That line is called the axis of symmetry. Axis of symmetry. Axis of symmetry. Very good, very good. So all parabolas come equipped with an axis of symmetry. The intersection of the axis of symmetry and the parabola is called the vertex of the parabola, vertex. Okay, this point. Here you have the graph of a quadratic function, shows a parabola. You have here the axis of symmetry. This intersection of axis of symmetry and the parabola is called the vertex. You are looking at the y-intercept here. These are x-intercepts, right? All right, so now let's go in details into how the graph of the quadratic function is going to look like according to the sign of this leading coefficient a. Given f of x equal ax squared plus bx plus c, if a is positive, then the parabola opens upward. You will get something like this. Now, that can be easily remembered if you follow this mnemonic device. If you remember the mouth or the lips of a happy face, that will show you this shape, right? For a greater than 0. If a is less than 0, however, the parabola will open downward this way. That is easy to remember if you kind of look at the mouth of a frown face, right? This way now. This will be the shape, right? Opening downward. Now, further, there is a way to find the coordinates of the vertex of the parabola and the equation of the axis of symmetry. F of x equal ax squared plus bx plus c can be written in a standard form. A stays the same, as you can see, but these numbers, h and k, appear here inside, here outside, right? This together, h and k, will give you the coordinates of the vertex, important point of the parabola, right? Now, there is a formula that mathematicians have figured out to compute h and k. H will be equal to minus b over twice a, very important formula. And k will be the result of plugging this minus b over twice a into your function, So this f of minus b over twice a. So that is how you find h and k. First you compute h, and then you plug h into the function f, and then you get k. H comma k, vertex of the parabola. The axis of symmetry is given by the equation x equal, you just take this down here, x equal h, x equal minus b over 2a. Or equivalently, x equal h, right? Same. Okay, example, given this quadratic function, find the vertex and axis of symmetry, write f of x in a standard form, graph f of x. All right, let's do it. First, for part A, I have to find the vertex and the axis of symmetry. So quickly, f of x equal twice x squared minus 4x plus 5 tells me that A should be just the number 2, right? B should be this number -4, right? C is 5, but for the computation of the vertex, we don't need C, right? C is needed when you solve a quadratic equation, for example, right? But not here, not in this context. So the vertex should be the following. It will have a first coordinate h given by this formula, minus b over twice a. But what is that? Minus 4. Remember, b is -4. Divide by twice a, twice 2, right? Very good. So doing the math here, minus 4. This is 4. 4 over 4 is just 1. Now I found h is equal to 1. How can I find k? Remember, k is going to be what you will get when you plug your h that you found into your quadratic function, this function, right? So let's do that. So this is going to be twice 1 squared minus 4 times 1 plus 5, right? Remember, x is just a placeholder. So if you do this, this is 1 times 2, 2 minus 4 minus 2 minus 4 minus 2 plus 5 is just 3. So first coordinate h1, second coordinate of the vertex k3, right? 3. So k equal 3 tells me that the vertex then, the vertex of this parabola should be h comma k, right? But what is that? H is 1, k is 3, right? It's 3. So this is the vertex. Very important that you find the vertex. It has a lot of information encapsulated there. All right, so now part B, they say they want you to write this quadratic equation in what mathematicians call a standard form, in this form, right? This form. Well, I have that A is 2, right? The leading coefficient. Notice H is 1 and K is 3, right? 3. Sometimes it's a good idea to do this. If you just want to write straight what goes inside here, take the opposite of this, 1 minus 1, right? However, when you are dealing with the second coordinate, take this as it is, right? Maybe we should write a note here, right? To go from here to the equation in standard form, opposite, right? 1 minus 1. To go from here to here, same. This will help you when you do your homework, you will see. Okay, great. So this is the equation of this quadratic function in a standard form, right? Don't forget the 2 here, square. Very good. So now, this is a standard form, right? Standard form. Very good. Now, they want the graph. Sparse here, right? The graph. For the graph, guys, we know the vertex, so quickly set the vertex on the plane. 1,3, right? 1,3. Where is that? 1 to the right, 3 up, right? That's clearly the vertex here. Very good. This is the vertex, 1,3 vertex. Now, A is greater than 0, right? A is greater than 0 because 2 is greater than 0. So I am dealing with a happy face. I know my parabola has to open upward, right? Upward from here, from this vertex, right? Upward. But how narrow is going to be my parabola? How wide? I don't know, right? In order to have an idea, use the y-intercept. Find y-intercept, right? This will give you an idea. You will see. To find the y-intercept, we let the other variable, in this case x, to be 0, and we evaluate at 0 our quadratic function, right? That will be the y-intercept. So that will be the quadratic function, remember, is 2x squared, but x is 0 in this case, minus 4x, minus 4 times 0, plus 5. This disappear. F of 0 is 5. 5, Professor, the same as C. Yes, correct. Always this guy gives you the y-intercept. It's a property. I'm going to mark here. Y-intercept. Between quotation, because it tells you what the y-intercept should be, right? So the y-intercept should be 0, comma, this guy, 5, right? Very good. 0,5 the y-intercept. So 0, I don't move to the right, I don't move to the left. I go just 1, 2, 3, 4, 5 up, right? 5 up is here, right? 5 up here. This is the y-intercept. I have my y-intercept here. Then remember, parabolas show vertical symmetry, right? By the way, the axis of symmetry should be here, right? So knowing that parabola show, just like the human body, vertical symmetry, I know that for this point, there will be another here, same distance from the x, or from the axis of symmetry, right? So reflect this point over here, and then you will get an extra point there. Now I have 3 points. Connect these 3 points. That should be enough to sketch your parabola, right? Yeah, very good. Connect these 3 with a curve nicely, and that's it. This is your parabola. Okay, very good. So when you don't have an idea of how wide, how narrow your parabola should be, use the y-intercept, right? It should help. Now they want the axis of symmetry. Well, this is the axis of symmetry, right? Its equation is x equal h, but h we found out was 1, right? X equal 1. This is the axis of symmetry, right? This guy. Axis of symmetry. Right? Okay, guys. So this is it. Now I want you to practice on the worksheets, okay? So let's do this too quickly. And then I will show you how to maximize or minimize quadratic functions, right? Using the coordinates of the vertex. Try to do the first one, right? It's straightforward. They say they give you this a quadratic function, they are asking you to figure out what should be the vertex, coordinates of the vertex as a point, and the axis of symmetry, right? Can you do that? Yeah, I'm gonna give a hint here, hint, vertex equal h comma k, h equal minus b over 2a, k equal the function evaluated at h, right? Follow that and follow your coordinates for the vertex. And then after that, x equal h is the axis of symmetry, right? Yeah, and remember the function here, f of x is equal to x squared plus 4x minus 5 with a equal 1, b equal 4, right? So try this formula with a equal 1, b equal 4, and you should be good there. Yeah, let's go. Let's do it together because we're gonna cover more form. Okay. Yeah. So applying our formula, a should be minus b minus 4 over twice a, 2 times 1. But this is just minus 2, right? When you do the math. Therefore, k should be the evaluation of the function at -2, right? The evaluation of your quadratic function, this function at -2. Which is going to be just this, -2 squared plus 4 times -2 minus 5. And when you put this in the calculator, this is going to be 4 minus 5, 1 minus 8 minus, I think it's minus 9, right? You follow, guys? Yeah, very good, very good. Minus 9. So the vertex should be -2, comma -9. And the axis of symmetry will be given by x equal this guy, right? As it is, -2. Yeah, and that tells you that the answer should be this, right? Following? Very good. This one deals with the graph. Okay, I just gave you an example of this, right? So I think you should be okay with this. Or perhaps, let's see if it fits here. Yeah, perhaps we can do it, right? Can you try it? Find the vertex, right? Once you find the vertex, then use the vertex to see what is the lowest point of the parabola, right? And then clearly opens upward because a is 1. And with that, you should be able to graph this parabola, right? Yeah, f of x equal, let's do it here, right? X equal x squared minus 6x. A equal 1, B equal -6. Work with that, guys. And remember, vertex h comma k, h is always equal to this, minus b over twice a. That's the formula for h, right? Very important formula. And k is the function evaluated at whatever you get there. Mhm. Mhm. Yeah. All right, guys, let's do it together. Minus b should be minus minus 6 over twice a twice 1. Doing the math, this is 6, this is 2. 2 into 6 is 3. And the evaluation of the function at 3, okay, will be f of 3. You can do it here. 3 squared minus 6 times 3. This is 9. This is negative 18. So therefore, when you do the math, this is what you will get. I will show you now. Yeah, minus 6 twice 8. Yeah, we agree that this is 3. So f evaluated at 3 is equal to 3 squared minus 6 times 3, which is negative 18 subtracted from 9, negative 9, right? So the vertex is 3 comma negative 9. Okay, 3 comma negative 9. Look for that. This is a good one, right? 3 comma negative 9. Vertex. And that basically determines the answer because if you look through, the only one that is showing that, I think, is this 3 comma negative 9 is this, right? The rest you can confirm as I did in the example, guys. The y-intercept is 0. Then you get this other extra point for free, right? It's a reflection of this because of the vertical symmetry. And then you connect the 3 dots. It should be this. The x-intercept 0, 0, and 6, 0, right? You can do that yourself. Okay, let's go now over the last part, which is determining the maximum and minimum values of quadratic functions. Remember, when you graph a quadratic function, there are two possible scenarios, right? Just two possible scenarios. A happy phase, whenever the leading coefficient A is positive, right? The parabola is going to look like this. But notice that then there will be a lowest value for the output values, right? There will be a minimum, right, for your quadratic function. Now, similarly, right, if you are dealing with quadratic function whose leading coefficient is negative, the graph of this quadratic function will resemble the mouth of this front face, right? But notice that then we are talking about a maximum output value here, right? Maximum, so maximum. So now this minimum will occur at x equal minus b over twice a, because it's happening at the vertex of the parabola, right? You see it, guys? And the minimum value, the actual minimum output value, should be the evaluation of this guy into the function, right? That's it. Similarly here, the maximum will occur at x equal minus b over 2a, because it happens right at the vertex. And the maximum value will be the evaluation of your quadratic function at minus b over 2a, okay? So this gives us a way to maximize or minimize our quadratic functions, right? Using these formulas. Let me show you an example of how you should do this. Example 1 says, given the function f of x equal to x squared minus 8x plus 13, find the minimum value of f of x. All right, so since we're looking for the minimum value, we have to first identify our a with 2, our b with negative 8. And then use this formula, right? The minimum happens right at the vertex, right? So x, the one that determines the minimum value, should be equal to minus b over 2a minus minus 8 over twice 2. This is positive 8. This is 4. 4 into 8. 4 into 8 is just 2, right? So 2 is the input value where the minimum output value will be achieved, right? Now, very often, it will be important to determine what that minimum value is, right? So just plug this into your quadratic function. Remember, x is a placeholder. Do this. Look, this is going to be 4 times 2, 8. 8 minus 16 minus 8 minus 8 plus 13 is just 5. 5, right? So 5 is going to be the minimum value, right? Minimum value. So this guy, minimum value. Output value. And this is what you are supposed to find, guys, because they will give you, for example, a cost function. They will ask you to minimize the cost function, or they will give you maybe perhaps a profit function. They will ask you to maximize your profit function. So let's use these formulas and let's do it. I'm going to show you some examples first, and then I will ask you to do some work on your own, okay? So these ones can be covered with the example I just did, right? But these word problems are the ones that probably you may need help with. For example, I'm going to show you how to do number 5 here, okay? Number 5. It says a rock is propelled upward from the top of a building 180 feet tall at an initial velocity of 56 feet per second. The function that describes the height of the rocket in terms of time is this: s of t equal minus 16t squared plus 56 times t plus 180. Determine the maximum height, important word here, maximum height that the rock reaches. Okay, guys, so we have given here our height function, let's call it, right? Or sometimes also called position function. This is it. Physicists have figured this out. We have it. Now, the maximum height will occur at what value of t? Well, at t equal minus b over twice a, right? Because remember, it happens at the vertex. So this is something that we need to compute. B is clearly 56, right? Twice A is clearly negative 16 here. So we're gonna do this computation. Now, guys, for this computation, you need the calculator. It will be very difficult to do it using mental mathematics. So use your scientific calculator. Minus 56 on the top divided by 2 times minus 16. 1.75, right? 1.75, write it out here, 1.75. So what does this mean? It means that at 1.75 seconds, this height will be maximized, right? It's like maybe a diagram may help, right? This is the building, and you are throwing this object, it will reach some maximum height and it will fall, right? That maximum height will occur at this time, 1.75, right there. But now they are asking you to figure out what is this actual maximum height, right? Actual maximum height. And for that, simply now do the evaluation of this guy into your position function, which is this, right? So this will lead to minus 16 times 1.75 squared plus 56 times 1.75 plus 180, right? You gotta compute this in the calculator, guys, otherwise it will be difficult. Minus 16 times 1.75 squared plus 56 times 1.75 plus 180, right? Plus 180. I get 229. 229. In the end, feel free to attach the units. 229 feet, right? 29 feet. Turns out this is the maximum height, right? This is the maximum height that will be achieved. You follow, guys? 229 feet, which is here. Great. Now, can you try number 7? Give it a shot here. If you get stuck, I will help you out. This says the owner of a video store has determined that the cost C in dollars of operating the store is approximately given by this cost function, right? 2x squared minus 28x plus 730, where x is the number of videos rented daily. Find the lowest, meaning the minimum, right? Minimum value, lowest cost, minimum cost to the nearest dollar. This is the function hint. The minimum cost will occur, minimum cost will occur at x equal minus b over twice a, right? This is your A2, this is your B minus 28. So plug this in. Once you get it, that will be the input value. You substitute that into your function, you should get the output value, right? Try this, guys. A equal to B equal negative 28, right? Substitute this, get it, get the input value. With that input value, substitute it into your cost formula. And that should be the minimum cost, right? Minimum cost. Yeah, maybe a diagram also may reinforce this idea. Right? There is a cost function that looks like a parabola that opens upwards. How do you know, Professor, opens upward? Because of the happy face that this tells us, right? The leading coefficient being positive, happy face, this is this. So they are asking you to figure out where this minimum cost happens, right? And this is going to be here. It will happen at minus b over 2a, right? Yeah, go ahead, guys. Try this. And you need a calculator there, right? So try to use your scientific calculator there. Okay, guys, let's do it together, okay? So we can go over more forms. X will be equal to minus b. B is negative 28 over twice a. Twice a is 2, right? This is 4, this is 28. 4 into 28, 7, right? So what is this telling me? It's telling me that this is going to happen, this minimum cost is going to happen at x equals 7, at x equals 7, right? But now they're asking us for the actual minimum cost, right? Which is just the output value associated with this input value 7, right? So we plug into our cost function 7, and we're gonna do this, right? 2 times 7 is squared minus 28 times 7 plus 730, right? Let's use our calculator, guys. So 2 times 7 squared minus 28 times 7 plus 730, right? 632. 632. In the end, attach the unit dollars, right? $632. $32. This is what the minimum cost is, right? Very good. Okay, guys, now try this one. Number 9, I think is a good example. It's another video store, but now the owner of a video store has determined that the profit P of the store are approximately given by this function. P of x equal minus x squared plus 20x plus 51, where x is the number of videos rented daily. Find the maximum, now the maximum profit to the nearest dollar, right? To the nearest dollar. So go ahead. Now it's about maximizing the profit, right? Remember, the maximum profit will happen at x equal minus b over 2a, right? A is equal to -1, right? B is equal to 20, right? So can you try this, guys? Put this in there. And when you have your value of x, they want the maximum profit. So you replace that into your function, right? Into your quadratic function here. Graphically, this basically is telling you that if you have some profit function that's going to look like this, how do you know, professor, will look like this? Well, because it resembles a frown face. A equal -1 is less than 0, so frown face, right? So they are asking you to figure out where this happens first, right? It will happen at x equal minus b over twice a. And then further, what is this value? The maximum value for the profit, right? For the profit. Minus. Okay, guys, let's try to do it together, okay? So we have a way to maximize and to minimize quadratic functions efficiently. Right, so let's follow that. So in order to maximize this profit function, it will happen at x equal minus b over 2a. So this is going to be minus 20 over twice times 2 times -1. Is -20, -2. -2 into -20 is just 10, right? 10, guys. So now this is when the profit you get maximized, the input value, right? But we want to find the actual maximum profit, right? The output value associated to 10. So that shouldn't be difficult because you just have to plug this 10 into your quadratic profit function, right? And remembering that x is just a placeholder, this is what you have to do, right? In your calculator. 51, let's do it together. Minus 10 squared plus 20 times 10 plus 51, 151, right? In the end, feel free to attach the units, $151, right, for the maximum profit. So this is this 151 is the maximum profit, right? No matter what you do, the owner of this video store cannot achieve more than 151, right? This is the importance of this maximization, minimization problem, right? It also gives you a bound, an upper bound, a lower bound sometimes, right? Which is important to keep in mind. All right, so the answer should be this one, right? Very good. Okay, let's finish with this one. number 10. So you can have more examples for your homework. It says the manufacturer of a CD player has found that the revenue, R in dollars, is RP minus 5P squared plus 1,800P. When the unit price is P dollars, right? If the manufacturer sets the price P to maximize revenue, what is the maximum revenue, right? Keyword here, maximum, to the nearest whole dollar. All right, let's do it. A equal -5, B equal 1,800. And now we know that this maximum revenue will occur at X equal, or in this case, to be formal, at P equal, right? Because the input value is represented by P, at P equal minus B over twice A, right? But what is that? Well, minus, this is B, 1,800 over twice A, twice -5. This twice -5 is -10, -10 into 1,800, it will be 180, right? You can compute this in your calculator if needed. But this tells you basically where, right? Where the revenue will get maximized, right? The revenue when graph will function, the revenue function when graph will look like this. How do you know, Professor? Because it's a frown face. The leading coefficient A is negative, right? Frown face. So they are asking you guys to figure out what is this output value, right? Associated to the input value that we just found out is 180. All right, so unit price 180, right, leads to the maximum revenue here. All right, so simply plug this into your revenue function, right? To find out what is the actual maximum value for the revenue, right? So you're gonna do this. And follow the instructions, guys. It says when you get this done, round it to the nearest whole number, right? So let's do it together. So we'll have -5 times 180. Notice how I'm using parentheses, guys. It helps a lot, the use of parentheses, especially if you are substituting negative values on your functions, right? So consider that times 180. Aha, I get 162,000, right? 162,000. Attach the units in the end, 162,000 dollars, right? Dollars for the maximum revenue. And that is here. Mm-hmm. All right, so this 162,000. Very good, guys.